me okay? Oh, this is like my shadow scene. Hello, Kofi, Praveen. Bit late at the moment it seems. I also have a. Let's have a look. I think there's something wrong with it, but what can I do? uh, is it better now? Please let me know. Okay, let me just check if it has any filter. Okay, is it is it very garbled or is it just like very low? Okay, cool. 1 second. Okay, so today I have a very dangerous proposition, and it's basically uh, starting off with physical computing. I have been trying to experiment with it a bit over the past few months over the summer when there was a second lockdown. But I'm sort of fairly new to the field, and I know very, very, very little about it. So I will just kind of start off with some basics that I've been looking at, and then we can try to see what how we can do the setup and figure things out. So I think many people already know about the Arduino board, and the Arduino board is like a small microcontroller. A microcontroller is like a well, I would. Oops, sorry for that. It's not a mini. It's not a mini computer per se, which is more like a Raspberry Pi, but it's more of a like single set of things that it'll do. Whereas a Raspberry Pi is like almost a mini computer of sorts. So the Arduino boards have been around since maybe like early 2000s, I think, and they've like really proliferated across. Of course, people use them a lot in IoT, but they seem to have a special uh, love in the creator community because you can do quick, simple, fun prototypes with them, and people have done some really amazing work with it. And the Raspberry Pi Foundation, which makes the Raspberry Pi computers, also made a microcontroller recently, which is $4, or I don't know, equivalent in rupees, maybe couple of hundred rupees. Yeah, 300 rupees. So in that sense, it's fairly cheaper than the Arduino boards, which can go into the thousands range, but it's also very limited because it doesn't have a lot of the functionalities that Arduino boards tend to have nowadays, and are kind of expected because people want connectivity to the internet and things like that. But where I wanted to start off today was very simple to see, like, if I can just connect a simple little OLED screen to the Arduino board, sorry, to the Raspberry Pico, and then see what we can do with CircuitPython, which is like a MicroPython based framework that's kind of supported and developed a lot by the Adafruit organization. If you guys don't know Adafruit, it's this really cool, very, very exciting makerspace platform where they build a lot of their own electronics, and it is all women run. And the founder, of course, is also a woman. She goes by Lady Ada. Can maybe show you something about their team. I don't know if it's there. So, I mean, of course, it's like a diverse group of people, but I think the main people in the board and this business decision making are all women. And one second. And they have a very nice tutorial that you can use for your Pico boards, and also for using CircuitPython in general if you'd like to. So we'll just quickly look at how you can start off with your Pico board. It's pretty simple. There's a little board here which you can see. It's fairly small. It's like maybe a couple of centimeters only, and the chip itself is like smaller than my fingernail, and it has a bunch of I/O pins on it, and I've just connected it to a breadboard. So yeah, let me just fix it back to a nice place. Yeah. So what I'm thinking of is like, let me first start and figure out how to get a bunch of like text going on it, and then see if I can like build it into a small like generative text, like a little poetry kind of a format. I haven't really thought about how it will work because I've never used Python before, but I can tell you what I've already done in terms of the setup. The setup starts off very simply. We have to first install a small UF file, which kind of like is like a little bootloader onto this particular board. It'll automatically reformat into the CircuitPython format, and then from there you install this code editor called Mu. I'll just show it to you as well. This is the website. I've just posted the link as well, and this is the board, and then you just install it to your install this file to your board, and then you start a coding IDE or whatever. Hi Kushal, how are you? So sorry, there may be a delay between you guys telling me in the chat and the chat reaching me as well. But I just started off. We are trying to connect this little board here to this little OLED screen here. These are the screens that you typically see in your like smartwatches and I don't know, bunch of other, I guess, IoT type things. And it's not flickering actually, it's just that the frame rate of this animation is slower than the camera frame rate, because the camera is like a camera and this is just a small little board which is like $200. So this is not Arduino, this is based on Python. It's called CircuitPython, and this is what I was just talking about here, which is this. So it needs a simple, I mean it recommends a simple IDE called Mu, and Mu is basically allows you to like learn simple stuff in Python based coding, and you can kind of choose which controller board you're using. You can even see Lego has their own MicroPython, and there is also the BBC Microbit, which is very well known. and it's fairly simple. It's like any other ID, like the processing ID or whatever, but the only difference is that once you're connected to the board, it'll give you a little console which tells you what's happening on the board. So we'll now I'll kind of give you a sense of how I've connected the board and a bit about the GPIO pins on the board. And then we will take it from there. So yeah, so this is the other. Can you guys hear the pataka, the fireworks? Probably you can. Okay, sorry about that, but I guess we have to deal with it. So basically, this is the kind of the USB port, and then these are your pins, which are kind of giving you input output, and they have some specifications for like how they can be used. I really don't know too much about it, but I do know some basic things like these are the ground pins for your connections, like the ones that are in black, and these are few which give you power, like here, and I think there should be another power one somewhere here. Maybe it's just these two, and of course this is your USB, and this is the main chip that we saw on the board. So the way we'll set it up is that first we will just check in the REPL what it looks like, and then from there on we will kind of take it to a more complex place of building this little program that we have here. So the way it'll work is that I'm just gonna do like print hello, like we do console log hello in P5Js, but here it's print. I think people in who are using processing know this as well. So when I hit that, here you can see that it's giving me a little hello, and now you can see that the board doesn't show the text anymore. The OLED display. It just shows me press any key to use the REPL, which is this space at the bottom. So I will hit enter, and then you can see that there are 3 arrows and it's given me a little REPL. By the way, this comes out from this button here, serial. Oh wait, let me just move to that screen. So yeah, so I open this and I'll move to, so it says hello now, and you can see here it's giving me exactly whatever was said in the console, in the serial console at the bottom. So the REPL is open now, and I will write import board. I think you're coming in from processing, you will know a little bit about this stuff also, like there are modules that you need to import to start off, and then I will write board dir or dir board. Let me just see, I think it's the other way around. So dir board. So this is going to give me all the IO pins on the board just to know, and I think this is more or less what we saw in that little PDF that we were looking at, which was here. So this is pretty much the same. Maybe I'll move this a bit for you guys to see. Here you can see all the GPIO pins have been given, and some of them have particularly you can observe that some of them have this little number here, which is like showing up as A1, A0, or GP, or GP26A0. So I think the A1s particularly are meant for analog inputs. So this could include like potentiometers, little switches, something to do with other kinds of resistors and voltage, whereas there are some digital pins, and of course there's an LED. There's a like a tiny little LED here. Maybe I can show it with a pencil. It is here where the pencil is kind of pointing. So I'll show you how you can use that as well, and we'll get to that pretty much in a minute. So what will happen now is I'll have to keep switching between the web and this this IDE, but like kind of just bear with me if I delay in showing the IDE in at the right time. So we did a bit of Hello World and we saw that it was working fine. Now we'll just do a loop. Now a loop is a little bit different from how the loop is in P5JS, which is what I'm used to, but I just kind of figured that this seems to be so easy to do actually. So I'll move back to the board. So here you can see that it says print loop starting, and then it says for I in a range of 10, print the loop number, and then print the number that it's printing, and then say loop finished. And then you see that there's an indentation. So the indentation is pretty much like how we have in JavaScript. So this is exactly like writing for I equals 0, I is less than 10, and I plus plus, and then you're putting your code in the middle of this loop. This is exactly what's happening. And then at the end of it, you're saying then loop finish. So you're just doing another print. So of course this will not work in the same way. Here it's like you're writing out the range, and then you're putting a colon, and then you put a tab, and then you write the rest of it out. I don't know, maybe Kofi already knows this, or maybe even Kushal. So I'll play it again. Okay, once so I think I have to exit. Yeah, so I'll play it again. So you can see that it's run the loop from 0 all the way up till 9, which is like the range till 10, and then you do loop finished. Now you can also like do, okay, run it from 9 to say 20, and then it'll do the same thing. It'll run it from 9 and up till 19. And then you can even add a counter. So this is exactly when we write I plus plus, or sometimes we write I plus equals to 10. So this is the counter. So here maybe we'll put a counter of 4. So when we do that, you'll see that it's added 9 plus 4, 13 plus 4, 17, etc. So I think it's pretty easy and like quite fun to do. Free code camp Python code tutorial. Yeah, oh my god, I just can't do any of those tutorials. So I just figured that maybe this is the way I learn Python, because I'm not able to learn it normally. So I just figured this out like as of half an hour ago. So anyway, so you can use loops very simply here. You can use the REPL to do some kind of interactive stuff. I'll just quickly shift to that page here. And then finally, we'll look at how we can kind of start working with the two together. So now we already did import board, and we figured out what points go where. So there are certain kinds of outputs. So I2C actually stands for I squared C, and then there is SPI and UART. I think today we're going to use I squared C. Please don't ask me what these things mean. I'm also still figuring all of this out. But in general, it's I'll just kind of, before we start off with I squared C and all of that, we'll just kind of first look at how we can make this LED on the top blink a little bit. So I'll just run you through the code here. So you have to do an import board, and then you have to import the digital IO, which is basically digital input output. So here it's actually just the board LED. So there is no GPIO number like we had here on the pins. Here you can see this is the LED, and it's the nomenclature for it is board.led. Whereas in the other formats, you may have had to write board.gp pin 0 or whatever, something like that. So I'm just going to copy this code out and add it to the Python IDE. And hopefully this will make the LED light up. Yeah, so now you can see the LED is lit up. Uh, can you guys see that? Isn't it always the case? But I was also thinking that Python might be interesting to some people because like people using Touch Designer and Rhino and all, I think they need Python, right? They don't use JavaScript and all of this stuff. Yeah. So now we've got a green light. Now we'll quickly see what are the other kinds of things that are happening. The way it's working is pretty simple. You imported the IO and the digital IO and the board. You gave the variable digital IO dot digital in out to the LED pin, and then you gave it a direction which is related to making it an output. Oh my god, that sounds even scarier. C sharp is not nice sounding at all. And then you just give it a value of true. So what one could do is based on this, sorry, give me a second. Based on this, we could kind of make a little Boolean variable. So we could say that while true, which is basically like saying if x equals to 0 or true, and then moving from there on to uh, changing it out to if it's true, let it be true. If it's false, let it be false. I think this should give us like a blink on off on off. But it's so fast that we may not see it, but I'll still try it out. So it happened briefly, but you can't really see it. So we can add a variable for, they have a variable for like it to sleep. I think this is also a processing terminology where you can like put a little bit of time where it's pausing. And once you do that, it kind of does a, oh, did I put an error somewhere? Oh, we forgot to import time. So now you can see that it's kind of moving at like half a second. I can change this to being very fast. So I don't know how fast this will be. Yeah, so now it's like epileptic, or it could be super slow, like every 1 minute, 1 second, sorry, one full second. So yeah, and of course, there are some things about Python which I'm still learning. So apparently, you can just, in a very confusing kind of way, make it very, very strange and say that if the LED value, if true LED value equals LED value, not LED value. I don't know how it works. It's so weird. And then put the sleep function again and then hit save, and then it'll do the same thing again. I don't know how that works. It's so weird. Anyway, I'm also figuring stuff out. Hi Anushka, you can please help us with Python. So yeah, so we are basically at a point. This is like very few people today, so I'm just going to like repeat myself. That we are at a point where we are just trying to like figure out how this little board here works. It's a microcontroller like an Arduino, but it's running CircuitPython, and then uh, no, oh, can I like minus some points from Kushal? And then we'll run a little bit of text here, and then I want to see if there's a way for us to like maybe use Python and then like make a generative little text which keeps moving. I don't know how long my energy will last and your energy will last, so we'll give ourselves like say another 50 minutes and see where we go from there. uh, so when they make a language called cats, you learn it. I think maybe in the next stream we should make a plugin that anytime someone says meow, it maybe like goes and signs a petition for somebody to make a language called cats. Anushka, sorry, Kushal. Okay, so So the reason it's flickering is not because there's something wrong with the board, but it's just a difference between the frame rate of the camera and the frame rate of the refresh rate of the screen. So sorry about that, just bear with it. So yeah, so we are now at a point where we've kind of like doing this little blinky program thing that's running, and now I just want to kind of take it a bit further and see if I can run this OLED display with a little bit of text on it. So of course I'm not a full fool. I'm a bit of a fool only. So I already found some bits of code here and there, and then I kind of patched it together and figured that it's working. So this particular OLED has a specified name, which is called SSD 1306. And all I did was write CircuitPython with it. And I did Adafruit, and then it gave me a particular tutorial which I will kind of play off of, and I will also share the link to. It's using another board called a Feather Wing or something with an which has a OLED already attached to it or something like that. But I just kind of winged it, and I figured some things out on my own and some things off of the internet. uh, well, Cat and Yugen same. So this is a 128 by 64 pixels screen, which is kind of like this one here. I don't know if you guys can see it. Yeah, you can. And the way it's connected, it has like 4 connections to it. I don't even know if I can zoom in so close to it, because it's like my system is like super jugaad how I'm putting it across to you guys. So yeah, so this is basically and the digital signals is SD and SCL, and then there is a VCC, which is the power, and then there's a GND, which is the ground. So the way that I was able to set it up was that at least with ground and power, I could just see the pin board diagram and say that okay, this is power, this is like the fifth one from the top on the right side. So I use that for power, and this is ground, but I could use any of these grounds also. And then I know that it says SD, SCL and SDA, and you can already see here that some of them are marked as so, and these are all I squared C. These all give output for I squared C. So I've already like put them in on these two here, 6 and 7. Okay, and now what I'll do is now I'll just show you the code for what these guys have done in their tutorial here. So yeah, so now just like we imported where did that thing go? Just like we imported board and digital IO and time, similarly we'll have to import display IO and for the SSD 1306, which is this, and bus device, which I think, if I am not wrong, is related to USB, but I could be grossly wrong, and please correct me if you guys know anything. And additionally, there are some additional libraries for CircuitPython, including text. So I have that also installed, and they are all in the, oh yeah. So basically, one second, let me just show that to you guys also. Let's see if it picks up. Oh, it doesn't. Sorry. One second, guys. Okay, I'm just doing a full screen capture for a minute to show you guys something. So this is basically like when I plug the CircuitPython, it just gives me a bunch of files which are more or less empty when you start off, and then you can kind of add the libraries that you want. So I've added these particular, so the bus device, display IO, the specific display IO, one smaller file, and then the display text library. And my code.py is where the code is running. A bunch of these are just some things I was trying out, so they bear no sort of sentiment to what we're doing. So yeah, so basically now at this point we need to add another two or three libraries, which where am I? Get back to here. Which are basically for the display IO and for that specific particular IO that we are using, and then the text. So I already have this kind of setup, so I'm just gonna like copy this and take it to the other side. Right, so hopefully nothing should go bad in the code. I've saved it. So now I'll just like run you through, not this code, but on the website it's like very nicely given. So the first thing that you need to do is basically initialize your I2C on the board, and then kind of add it to the display. So how they've done it here is just made a variable for display bus, and made a display.io and initializing it with I2C, and then the device address. Now this I've kind of added ad hoc whatever they've done, and then from there on we've sorry. So now we've kind of addressed the fact that it basically needs to so the bus is like basically USB is also like bus, so it's basically a port that's allowing you to interface with this particular component. So and we are doing it from those 2 or 3 particular IO pins on the board. So this is allowing you to initialize that, and then after that you're initializing the display itself, and then you're saying that okay, run it through the display bus initialized I2C, and then you can define the width and height. So now these are of course like parameters that the library allows you to put. So if I already know that, I can perhaps just consider, 1 second, I need to keep switching this, it's a bit annoying, but what do I do? So now I can kind of, first I initialized I2C, and then I said these are the 2 ports that it's using. So which are the 2 pins that we have here, GP5 and GP4. And currently in our previous code, you'll see it's called board.led. Now we are going to call it board.gp5 and GP4. Then we are initializing the display bus, which is as I mentioned already, and then we are initializing the screen width. So now all these 3 things we'll kind of copy paste here. And then, okay, so now the tricky part starts. So let's just go through this tutorial a bit more and kind of figure it from there. So we've initialized all the ports, and now basically we need to start writing something onto the what is it called, the display. Yeah, I'm on Fedora now, sorry. If width and height, I'm wondering what happens if different width and height is given. So basically we just need to define it not based on something we've written, but based on the particular component that we buy. So I have to be kind of a little bit like conscientious in understanding what this particular component is. So for example, I can just show you what I bought off of the internet. So I went to this like local component, local as in Indian component, this thing, and then I just googled OLED display, and I was very confused. So I saw whichever had the least number of IO pins and which did not look overly priced. So I bought a bunch of them. So I bought 2 of these ones which look a bit square, and then I have another one which I was building for Agat into this, which is like which is this one. So it's kind of similar, and it's also running on a Raspberry. There are two Raspberry Picos. So I'll show you that as well in a bit. I don't want to go there. I don't want to go there. Okay, wait. Oh, I didn't even show it to you guys. Sorry. Wait. So this is one, and then the other one is this. This is like 91.91 inches, and this one is 0.96 inches. And both of them are with 4 inputs. Yeah, they kind of do look like that. I don't know if those were better or these are better. Maybe those were better because they were Nokia, I guess. But yeah, the format is very similar, where there's like only like one black and one color pixel in a sense. So yeah, so these are like not so expensive also to buy. So like essentially this is like, if this is like 200-300 rupees and this is another 300 rupees, in all you haven't spent too much money. Like the Arduino board itself will be about 1,000 plus, I think, or 900, at least 900 rupees. So like it's a good place to start without feeling like you're going to end up wasting a lot of money. Yeah, so I just bought this off this website, and then when you're buying it, you can see all of the kind. So like it says I squared C here, and it gives you the chip controlling chip number and things like that. So and what color the light will be, etc. And then just kind of you can see the back and the front and all. So the thing to bear in mind, like when you're getting into this stuff, which I know very limitedly now with thank you, an anonymous cheerer. Say hello to us also. So probably even Formula 10 won't destroy. I love Nokia, man. Seriously. The architect has spoken, so I guess it must be true that the building would fall, but Nokia would survive. So anyway, so yeah, so sometimes we tend to see these tutorials on the net, and they tend to be oriented like west way, and what ends up happening is that sometimes those components you don't get exactly the same thing, so you have to do a bit of like research before you buy things, or you can wing it also, which is totally cool as well. But you need to kind of sense that okay, how these things will pair up together and plan it out a bit. Otherwise you just end up rebuying a lot of things, which did happen to me as well. But I think once you get a sense of how they sit together and you've seen a few tutorials, it's hey schizophrenics, not these are quite okay. Like 200 rupees is like a couple of it's like like less than $4 US. So in that sense I think it's okay. But like if I were to buy the same ones that you get in the West, like Adafruit or whatever, and shouldn't they do it themselves if it's a component specific thing? So yeah, so basically, okay, so now these are going to different directions, the conversation. So I'll first close on the hardware. So yeah, so like uh, it's like if you want to buy the ones that you see in the West, they tend to have a very high like import cost attached to them, and then you end up paying a lot more. Although definitely when you hold the components in your hands, you can see a quality difference. But essentially, it's okay. Like I feel like when you're trying out, so sometimes if it's a little bit cheaper, you may also need to buy two eventually. But like those two will still be cheaper than buying something of Adafruit or Pimeroni for us in India. So so like the cost is quite okay. We're not paying too much specifically. Coming back to what Ophelia is saying, that shouldn't they do it themselves if it's a so yeah, so the components, so basically CircuitPython is like it's just a framework that anybody can use, and they've built as many libraries for almost all generic components. So generic components may be different based on who's built them. There might be just slight differences. Those could be of quality also, but they could be of like which chip you're using, or like how it functions and how many IOs it needs, etc. So some things they give you generically, so which is why they were able to give us for the OLED a library with parameter for width and height, but they weren't able to give us I mean, you can, I think, probably defaults to 124 or something, but it makes sense for us to be a little conscientious and write down those things or know those things before we start going crazy and purchasing everything and not really knowing where it's going from there. We'll go back to the web page once and then see where we were. I don't know if that answered your question though. There is only very limited soldering involved, where I took a bunch of okay, now I have to show that to you guys also. 1 second. And also, soldering is not as scary as it looks and not as expensive as it looks also. It's pretty cheap. And so you get these headers, and you can, I think, buy them separately or with the board. And then you just break this at the point where the header finishes. And then you just solder the smaller part to the top. And then you can like shove it into this breadboard thing that I have this. So that's useful. But if you buy I think if you buy an Arduino, it already comes with these little pins attached to it. So that way it's a little bit like more out of the box, easy to use. So like, I think that's the case, if I'm not wrong. So, I mean, it's not very different maybe in the cost also. Yeah, like here you can see this, more or less this looks like, if I take the board out now, the code will go. More or less looks like this here on both sides, and then you just kind of plonk it into this. I can actually show you the board even, maybe. Sorry. I'm kind of moving between the two things. Sorry about that, guys. So you can see here in this board, this other board that I have, which is also a Raspberry Pico. I don't have any header pins. I've just kind of directly soldered. Can you see it even? Wait. I've directly soldered shit to it, wires and whatever. And this one has the header pins. And then I have another one. Not a board though, but just to show you the component. Which is the same thing. Yes, so the pins are actually for reusability and actually testing, so that you can like move things around and test everything and all that. So it has these 4 pins, as you can see at the bottom, right? So then I can just like plonk it into this, and then I can like have my connector wires go into the board and whatever. So, but if you're just starting out, I recommend that you can, if you're finding a component with the header pins, you can, even if it's like a maybe 20-30 rupees or 100 rupees more also, it's worth it. 100 maybe not, 20-30. So yeah, so that's what it kind of looks like. Anyway, so now we'll head back to the web page with the code, which was here. Right. So, I mean, they give you the example code, but the tutorial is really nice, and it kind of gives you a sense of how you're using everything. So, once you've kind of imported all the modules for the library, you need to do a release display, which is basically like it doesn't automatically release the data through those I2C pins. You need to give it that one command. and once you do that, it kind of starts off. And then of course we set it to the particular width and height of the of the of the OLED display. If you put the height as less than it, it'll actually just make the code only in that bit. I didn't know that, and when I was slapping the code around, I saw a bit of that. And then so once we look at the larger code, you'll see that okay, so we did a release display, then we define the I squared C, and we define this the display uh, display with height, and where the I squared C is coming in from the bus. And then after that, there's a bunch of like really strange looking code, including something called group, and then some palettes, and then some kind of sprites, and then some kind of tile grids, and then finally you have the text at the very end. So we'll come to that as well now. So so the first thing that you have to do is kind of you set in a group, so the group can kind of define, okay, these are all the things that are combining and being shown onto the onto that OLED display. I don't know if that makes sense. And obviously because this has only two colors, you can do like a 0 1 kind of black and white. So they've done a color bitmap, and they've done the same thing. They've used the whole screen, and then said okay, palette 1, and then for the color palette 0, like as an array, they've put the white color, right? So because the display is monochrome, so you can see that it's all kind of here for you to read if you are particularly interested. So then post that, okay, so there is a hierarchy in how the display works. I'll try and find that little chart that they have. And then okay, so then finally once you've set that across, you can see it's kind of turned everything into white. So now here you can see the groups are really useful. You'll see that they've built a smaller internal bitmap group, which is like 118 by 20 of 24, and which is less than here you see, which is the size of the OLED display that they do have. So which they have now set to black. So basically it's like a white border with a black internal part now. So we can try this on the code environment and see what it gives us. So I'm going to remove all this at the bottom and see what happens if we run just this bit of the code. Hey, thanks for the sub. I wish I had an animation for it. But here's a purple heart. Okay. So yeah, I mean, nothing really happened, but also there was no error. It did a reboot, no worries. So then what we'll do is we have everything set up till the color, but we haven't called the color onto the what is it called, the keep forgetting the name, onto the onto the OLED. So let's just see how that will work out. I think if we do this, so now I've taken the color palette here as the shader, and I've called another library called tile grid. I have to find this for you and show it to you, and let's see if it works. And then I've appended that to my original group, my display group, which was called splash. And I've said the X should be at 0 and the Y should be at 0. So now these are kind of things that we know. And of course, color bitmap is here you can see it's for the whole screen. So hopefully this should give us the full white screen on the monitor, on the on the display. What is it doing? Oh, I'm on the wrong sheet. Damn. Okay, wait. This is the one that we are using, right? And so we've called the displays, and that's the last place we were. And now we'll call the splash group, we'll call the palette, and then we'll call the sprites. Okay, yeah, so now you can see that there is an error. It says that on line 11 you have an error in GP5. Okay, this could also just be a request for restarting because we've been doing a lot of stuff on it. Just give me a second. Hey, some power issue, but can you see like it's flickering and going a bit crazy? I think it needs to draw more power or something. Uh, is it visible to you guys? This crazy crazy shit that's happening here. Okay, I'll just kind of make it a little less crazy. One sec. So what I'll do now is I have this white background and I want to now give like a inside black background so it only looks like a white border of sorts. So let's see if this works. Same thing. I don't know why this error keeps happening nowadays. There you go. So now you can see that although my both the sides are looking fine, this. Hey, let me just like. Oh, I got my other display out. Maybe I'll just like use that one instead. Let's see what happens. This is me being like Jack Black and saying that you're not hardcore unless you live hardcore. But the legend of the Trent is way hardcore. Let's try this one now. Let's see if it works. Hey, it's a blue one. Nice. Good. This is better. Oh, sorry. Sorry, I didn't know it's coming in through that. Yeah, so okay. So this is now giving us this very nice blue, which unfortunately for you guys is like flickering like shit. But it's looking quite okay in my screen here, in real life here. So, but you can see it's like it's only taken 24 pixels to be black. So we can kind of like turn this up a little bit more. So you can see that here it's a 10 pixel difference, right? So that means 5 on the top and 5 on the bottom. Sorry, 5 on the left and 5 on the right. So we can maybe do that here as well. Let's see if 54 works. I don't know. Let's see. Damn, what is this issue? Yeah, so okay, well, let me just get this ASMR. Shall I get rid of that like thing if it's irritating you? Yeah, because this is running at a different refresh rate than the phone screen is phone uh, camera is kind of taking. So it's not flickering actually, but there's no way for me to show this to you. Please let ASMR be. Okay, yes, let's let ASMR be. So now we have this putty, like this little border. And then what we are going to do after this is we can think of either putting a triangle or just putting the text directly. But I think I'm just going to put the text directly and not really care about the triangle. I don't know if it's that useful. Let's see. And all the while you can see that the LED is still flashing because the LED code I haven't removed as of now. What the hell? Why is this like this? Yeah. I wish it was like P5, like keep on trying whatever. And then I'll add the text. What the hell? What is this kind of stupid restarting I'm having to do all the time? Okay, hold up. While your GP5 is in use. Yes, GP5 is in use. That's what I'm using. Oh, wait. This is where the release display might be useful. Oh, I was ill informed. Wait, sorry guys. Give me a minute. Let me figure this out. We give it a bit of a breather. Let's see if it'll help. And then also like check what this stupid shit means. Okay. Can you guys see the screen? Yeah. Yeah, that's what I was doing. Tadang tadang. What's going on? This is for PWM, so this is not what we were looking for. What the hell are these cards that seem to be auto-generated? See, this is why P5JS is so much better. Everything works without any issues. Okay. Okay, so since I have disconnected it, let me just quickly show you what the header thing looks like. From this. So yeah, so I kind of soldered these on my own. Wait, where do I show you? Right? Some of them are really badly soldered, but it's okay. Who cares? Like, I don't have to get any marks for this. At least not yet. So what I could do is maybe I can reset the code and then try to run it again to see what happened. So that is not that difficult, although it's also apparently a really silly thing because in Arduino it resets much more easily because there's a reset button or something like that. So what I'll do is I'll click this button here, some ASMR for you, and I have to keep it pressed and then put the power on. Okay, and now I'll show you my full screen, so then you can actually see what it is. Wait, was it here? Was it here? Can't find it. Ah, here it is. So here you see that it's gone back to like an RPy, RP2 something, and this like works very well with MicroPython. But I don't know. I was just like, okay, maybe Adafruit things, the documentation will be better. So I've been sticking to that. And for this, I have a little like a flashed kind of a file that you can. Okay, a lot of like private things on this, but okay, whatever. It was called something UF2. Yeah, this guy. So I just have to like drop this here, and then it automatically will reflash it, and it'll become CircuitPython on its own. Yeah, so now it's disconnected here and it's reconnected as CircuitPython. And I don't know if the code ends up being the same. I am uh IVO lol. No, actually I am running Fedora, which is a really stupid thing on my part. I moved from a Mac to a Windows because I couldn't afford an expensive Mac anymore. And then when I moved to Windows, I was like, okay, this is whatever. And then I was like, okay, Fedora, because someone told me. But I think if I would have used Ubuntu, things would have been a bit easier because a lot of the packages work way uh, way more easily on it. Uh, yeah, it's sensible. That's about it. But I am not sensible, so it doesn't work for me so well. Yeah. Uh, yeah. So okay. So for those who are super scared of soldering, it's not that hard. If you ever cooked anything in your life, you know how hot the temperature can be, and you can burn the food, and you can burn your fingers, and it's the same amount of risk. In fact, it's less because, at least in India, where we use gas cylinders, things can get even more dangerous. So even if you leave a solder on, at max it might hurt somebody, but I don't think you can blast the house. So don't worry about it. And soldering equipment is super cheap. You get it like, again, it can range from being like 400 rupees. I hate cooking too, but hardware overcooking for sure. Yes, hardware overcooking for 100% sure. So and there's a really good guide with Adafruit people, which I will put in the chat, which is a very nice set of YouTube links. Wait, I should have removed that while I was talking to you guys, but okay. Yeah, so this is basically what I have a I had a new laptop. Evo lol is saying that they have a new laptop. Okay, wait, I have to read. Can't wait. Alt F4 hardware lol. What is Alt F4? Oh, like you shut it down. Okay. I think your work will fit well with hardware. Yes, Illustrator is right, because a lot of good shader stuff can happen on Raspberry Pi with small displays, and Gonzalez has made a full library for that, or something for setup for that, and it's really cool. And he actually now has started to like reuse old displays and like connect them together, like old as in like discarded displays. And then okay, I had a new laptop I wanted to take to a conference. I wanted an OS that would just work. So yes, Fedora is pretty good, and I was actually able to, with the help of a very intelligent friend who also occasionally joins the stream, able to make a full mirror of my Windows OS on from one hard disk to another in like 5 minutes, and it was so cool. So yes, Fedora is very cool. Yes, even text and typography on displays looks great. So which is where I want this set of streams to go, that we are able to use, say, like e-paper displays or like small LCDs, things like that, so that we can build some interesting projects around that. Like, I don't know, maybe it'll be interesting to see what we could do with like uh, Twitch responses onto a little screen on something. I don't know. I'm just thinking about this. Have you got your I2C? Yeah, they worked a couple of times and then they stopped working. So I have reinstalled Raspberry Pi. No, the CircuitPython again to try it. Yes, Illust Pictures always supporting really fun, exciting things to be done. So yeah, okay. So now I'll reconnect this and stop talking so much. Okay, so now we can look at the pin boards again. So it'll give us a sense of what pins go where. And I will, 1 second, add this guy. Copy this camera here so you guys can see it. Maybe make it a little smaller. Yeah. So the pin board was here, right? So we know that we need V3V out, which is basically you're sending power out from the board to another component. So if you see that, that's 1, 2, 3, 4, the fifth one, right? And you see VCC is this green one here, which is the first one. Can you guys see it on the screen? Yeah, okay. And yes, you can use P5JS with Arduino because I think that Sarah Groff, whom you might know Illustrator from your live coding gigs, has made a P5 serial library for it. Okay, so this is the sixth one. 1, 2, 3, 4, 5. Okay. 1, 2, 3, 4, and 5. This one. And then is we need ground. Yeah. And the other thing you can do is that even in these boards, you can make them into HIDs, which is like human interface something devices. So just like mouse and mouse clicks and joystick, like joysticks like this, or keys like this. And then just like maybe just do like a small installation of that one thing and then just use it with mouse pressed or key pressed, which is what I've done in a particular post that I put a couple of months ago. Okay, so then we have ground, which is this orange guy, and the ground here is the third pin on this side. 1, 2, 3. Yeah. And then finally we need to put the SCL and SDA pins, for which I will go back to checking the wiring on this one. Here, yeah. Yeah. So SCL and SDA, and then we have to connect that to SDA and SCL, which is I think we were using 4 and 5, GPI 4 and 5, right? GPIO 4 and 5, yeah. So that is the sixth pin. GP is the number here, which is starting from 0, but this physically it's the sixth pin, and the SDA and SCL is the seventh pin. So I don't know if you guys can see it, but the extreme one here is SDA and this is SCL. So if I have to first take SCL, this will be on SCL is seventh one. Okay, 1, 2, 3, 4, 5, 6, and 7, and SDA should be the sixth one, which will give us GP4 and 5. Hopefully this is same triggers. Yeah. Sorry. So I'll just head back to the code here, so you'll see that this gives us the same GP4 and 5. So now, okay, cross your fingers, guys. If you made a simple Python Twitch bot, it could pick up people's messages, echo them. Yeah, so I want to do those kind of things, but I don't know how to use Python. So I'm still figuring this stuff out. Exactly. So like I was thinking, would it be interesting to maybe like have a little poetry bot which sits on a little display, and every time someone uses a particular word that and then it makes up a little poem and then it displays it. I think that would be pretty fun. Let's see. Okay, let's play this now and see what happens. Oh, okay. Something is not defined. GP5 is in use. Okay, let's just okay, no. So this is definitely nothing to do now with the rest of the wiring, but definitely something wrong in the code. So let's just kind of like trace back a bit and then see what was the issue. Damn, this is not working out. Hate when this happens. Just give me a minute. Let's see what happens. Okay, soft reboot code by output. Is there something to do like a hard reboot? I don't know if there's a way to check that. Use GPIO for 14 and 15. Okay, that's useful. Maybe okay, so that's a very wise idea. Let me just they are on the end of the board. Okay, we'll just show it to everybody once. They are, which ones did you mention? 14 and 15. Okay, so 14 and 15 are here. You see the last two, here, last two, and these are also SDA and SCL. Cool, let's try those. Should have given a bit more space. Okay, so which is which? SDA is 14. Cool. So let's try it again. Okay, what had we used it till? We did a full display and then we added this little one here. Okay, let's see if this works. Oh, the pin number has to be changed. Whoops. Okay, hang ho gaya hai. 1 second. I have to restart this. Give me a minute. Sorry, guys. How do you force quit in Fedora? 1 second. Mu just kind of crashed. Give me a minute. Yeah, so now I need to change this to what were they? 14 and 15. Okay, STA is 14 and this is 15. Okay, this seems to have crashed again. Give me a second, please. Sorry. Sys. Okay. Who are you, Evolol? You seem to know a lot about computers, much more than I do. uh, are you from India? Because we have a creative coding community, a small one. If you'd like to join. Okay, you're from Australia. Are you Indian? That is also okay to do. Okay. Isn't it like really late in Australia right now? It must be like what? Like, oh, maybe it's morning for you, isn't it? Yeah, maybe. Oh, okay. Okay. Good time then. Morning is good. Okay. Didn't seem to work, but let me see. Maybe we can get into the REPL and try something. Okay, line 12. Okay, so it is something to do with the. So maybe that display IO is not there because of that release display. Let me just add that bit of code. Hmm. Okay. Okay, my Mew is crashing. What the heck? Sorry. Bad word. Sorry. Okay. Just give me a minute. Okay. Change the added this. Okay. Everything seems fine. This is fine. Let's try now. Okay, so it's working now. Yay. I don't know what happened, but now it seems to be fine. Now what we'll do is we can now add the rest of the code that I was trying out, which included thanks Evo lol. Ivo lol? How do you prefer it? Uh, hmm. Okay. Uh, let's just try the text now. I don't want to like risk anything else now that this bit is working. And add the text. So again, this is coming in from the text imported text library that we have, and it's giving me something called a label. So it's taking a kind of generic library font which I didn't really want to change. And the text now you can add as a variable here. So I'll change this. And color, of course, is we can't really do much with color because it'll all come out to be the same. So perhaps I'll just make it white only, just to not really bother myself. And we continue to have the little LED flash thing going on, right? So, yay, subs gang. I don't know if you can see it with the wires. Thanks for the troubleshooting. Evo lol. Yes, that's what I love people on the streams for. It's like debugging all the time. No, it worked. No, I changed it to 14. That's probably why it was crashing, because I hit save without changing the code out. The pin from the board. So now it seems to be fine. Okay. Thank you. Yeah, so this is kind of sorted now. Now I just want to like look into what more we could do with Python per se in terms of the text. I don't know, like, can you do like things like random and stuff? I really don't know. Make font sizes and shit like that. I don't know. So we can kind of look into it. So, like, say for example, if you guys are okay to like have energy now, wait another maybe half an hour, maybe we can try to do like every 1 second or 2 seconds or maybe 5 seconds the sentence changes, and it changes out with like just a bunch of random arrays. uh, get it to read from serial, what does that mean? uh, and do I need another file, or can I just like build on this without really bothering? You can see there's a serial button. Yeah, so this serial is how second. Okay, so the console at the bottom. Okay, uh, okay. So you're saying that I can just try it in the REPL? Okay, that makes sense, I guess. Let's try that if it works here. Sure, like a print or whatever. I was just thinking maybe I can do it in the REPL if it opens the REPL, but I guess it's not doing that. But yeah, maybe we can just do a print to see what happens. So like instead of having the oops, what did I do? Instead of having the just a single string of text, I just decided maybe we can have an array of three of them, and then see if we can pick up like a random one from each of them, a random one every single time. But I think I may need, as far as I remember, some kind of an import random into CircuitPython, which I'll have to check. Yeah, let me just check the docs. Maybe it's needed. Uh, anything in the chat? Let me see. Okay. Okay, I'm just in the docs now for CircuitPython. I think they're a bit old because I think they're on 7 now. Okay, that's my son. Just give me a minute. back to sleeping now. Fortunate, I mean, I don't know. Let's see how long that lasts. So yeah, so we'll kind of like, let's get back to what we were trying. Sorry. So I was looking for if there was something to use random. Returns a random float between A and B. It may or may not be inclusive depending on the float rounding. Okay, so there are some built-in modules for random. Maybe we'll try those. Sorry. Random between 0 and 1. Between, okay. Maybe we'll do random from array. Okay. Choose multiple random items from a list. Oh, wow, this is so cool. Let's try it. Did you guys know this? This stuff is so easy. Okay, so we'll do print random choice text and see what happens. CC is not defined. Okay. So I'm just trying it in the REPL now instead. So it is saying random is not defined, which basically means it may need for us to import some kind of a random related module. So which is, let's just check. Here it is. So let's just import random and now try. Does it still say list? List object has no attribute. Okay, so does that mean this list and array are not the same thing? Probably. Aha, okay. Okay, let's go here. A randomly selected element from a given sequence raises index error when the sequence is empty. Random integer, random range, stop, random something, random seed. Okay. Circuit Python using array in choice. Okay, maybe it doesn't like to take random, so we could just use a range and then use the array input. I don't know. So maybe not too random, and then instead, oops, instead define like text based on time sleep. So like if the for range, what is it for I in range? Yeah, this is basically how you set up a for loop. For I in range of 0 to text dot length. Okay, wait, let me just try to run this in the REPL. Something seems so similar to list object has no attribute length. Okay. Python list dot length. Oh, len. Okay, okay, sorry. Need to know the, yeah. 39 wants a string as text. Okay. But we are giving it a list. Got it. So then can we like try this? The thing I'm trying now. Let's see. Text dot. Dude, I'm so out of my depth right now. 1 second. Let me show you guys what I'm looking at on the web. Print. Oh, okay, okay. So we can do len and then add texture 3. Okay. So then can I say and for I in text and I was okay, but it wanted a string, so it was like a random dot choice, but it needed a string. Okay, which means I'll go back to what I'm googling so that you guys can see. Okay, list. So this is your list, and then oh dude, this stuff is really quite something, but okay. What is the basic way to call it? Okay. Text area line wants a string label dot label. Okay. Aha, okay. Got it. So then I was correct in writing this, but I still needed to have a variable that said text2. Is that what you guys are saying? Okay. List. Okay. Maybe I'm still maybe a 1 or 2 moments away from it. Okay, when the REPL, let's just see what this means. So I'll put it 1 second here. I'll put it back in the REPL, which I did already. And then if I do print random choice dot text, it will still not be able to give me anything. Oh, okay. Okay. Now it's working. But it's always giving me Python and Pigeon, not anything else. Okay, it is giving me something else. Yay! Okay, so this is working. So import random I have added at the top, and then I have added random choice. here, and then made that text 2, and then made that text 2 here, and let's see again, let's try it. Okay, but so some reason it still wants a string. Maybe okay, let's head back into the REPL and so now I put the array back, then I said import random, then I said print random dot choice text. Okay, so maybe I say print, is there something for string? Okay, will it help if I do string, something like that? Python string. Is there a specific term for string? I think you have forgotten you're using text variable somewhere. No, but there I've added it as text2 here, which is here, and I took something from here, which is showing up in the REPL, if you see the REPL at the bottom. So every time now I'm doing a random, it's giving me one of the three. But somehow it's maybe it needs to be passed again as a string or something. So in JS normally there is an str function. I don't know if that's here as well. Let's just try it. No, maybe that will solve it, Ophelia. Do random dot choice text. One sec, I will turn to the web page that I'm looking at. Yeah, there is something str. So let me try that. Oops, still didn't buy it. Yeah, but it didn't work out. Okay, let's try it again. Yep, it's working now. I don't know what that was. So this is taking one random one at every go, and then maybe if we do like sleep and try it again, I don't know if that will work. Oops. So I'll do another one. I don't know if that will work out though. Can I do that? Like, I don't know how the way we just do it in. Oh, okay. I don't know. It was just like, for whatever reason, it wasn't working. I don't know if this will work. Okay, no, it's just happening that one first time, but after that, it's not working. Oh, sorry. One sec. I need to build something to help me switch from modes. Maybe that should be what I do. So every time I'm changing it out, it's working. Like every time I just hit save or whatever, but it's not working as per time, which is what I was interested in trying. So I wanted it to change like every few seconds. Like I don't know if it'll work. Let's see. Maybe I'll just do print here to check if it works. Yeah, okay. So this is fine. It is working. So if I okay, how would I do that? Do I need to rewrite it here? Like what if I just shifted this whole thing down? Okay. Okay. It is working, but it's kind of not, the screen isn't refreshing. I can see that it's overlapping on itself. Can see where the Python turns up. It is happening. So I don't know now how to do that. But Yugen is gonna wake up again, so I think I'm gonna go and kind of calm him down. Maybe we'll pick it up uh, another couple of days if you all are interested. So let me know. But if you want me to go back to P5JS, I'm happy to do that because I love P5JS. And also, oh, and I do have a few more things. So one is I have another board which is a Raspberry Pi which Nevos donated to me. So maybe we'll try something with that as well. And I have this project which I want to finish. So basically, this is not P5JS, which is this like macro board, uh, which has like two media keys and P5JS on Raspberry. That doesn't work too well because Raspberry Pi is like browser support is pretty shit, but we can still try. Okay, he's awake. And okay, let me have. One sec, give me a second. Okay, okay, guys, I have to go now. Bye, bye, bye.